Hello, let's do the solution to the now you try for the Hutton optimization. So here I asked you to do another optimization where we are replacing if some constant with the corresponding branch, right? So if true, then E else E prime should be E, and if false, then E else E prime should be E prime. So let's do that. So the way we do that is by pattern matching E. So if it's one of the base cases, we just leave it alone. It's a plus things. These things first. So if it's a plus of two things, we can just keep going deeper. And this is the interesting case. So what we should do, I think, is we should first optimize the E, because maybe that will make a difference. It's going to be something. We can forget what it is. So it's either going to be a bit, or it's going to be an if then else. Let's just change this back into EE. Because if it's not a bit, we have to keep it if EE something. So notice we are using the optimized EE here, because why away what we have done. And here we can keep optimizing E prime and E. Okay. But if it is a bit, then we can look at the bit. Do true case first, because it's if then else. So if it's true, then we can just return the optimized E prime. If it's false, okay, so that's a definition. But now, in order to convince ourselves that this is doing the right thing, we actually want to prove that it's sound, right? Meaning that we get the same evaluation if we first optimize or if we just leave it alone. So how do we prove this? Well, because this is pattern matching on the expression, we have to pattern match on the expression in the same way. So if it's a num, then the optimization is just returning the same thing. Evaluation is just going to return it. It's easy. Same thing for a bit. If it's plus, if, then we have a little bit more work to do. So if it's plus, then we see that this is going to be fine if only we knew that it was true for the sub-expressions. But thankfully we do. So the recursive calls in the sub-expressions. So that tells us that that first thing is okay, for example. Let's just rewrite by that. Similarly for the other sub-expression. See that after doing that, then we get these. This, of course, is the interesting case, because here we see that the left-hand side is stuck because it's waiting to do a width on this expression. That's what we did here. So we will do the same thing. And then we are going to anticipate that sometimes in some of these cases here, we are actually, so in particular in this case, right, we are actually using a value for E. So if you want to do a recursive call on that, you better do that here immediately. So that now. What we get is a value for E, the proof that it's sound. Okay, so then we look here again, and we see that the thing we are stuck on has now changed into this thing, which is good because here we can pattern match on that thing. So let's do that. It's either a bit, it's anything else. Deal with the if and else case first, perhaps. So what's going on here? Well, this is kind of looking good, right? So both of them are ifs. But here we have this complicated thing, and here we have that thing, but thankfully the recursive call says that they are the same. So maybe we can rewrite the recursive call. Okay, then that's looking better, but here these things are different, but that looked like other recursive calls. And because these expressions are mentioned in the width, it should be safe to just here. So what we want to do is we want to rewrite by it. Right? So just both recursive calls. That. And then we see that everything is lined up. That's okay. But of course, the interesting case is really this one where we actually do something, right? So what's going on here? Well, we are still stuck because we are doing a pattern matching on this bit x. So let's see what x actually is. True again. Okay, what do we have here? Well, it looks a bit complicated, right? So we have an if of a t-val of e, but we actually know here that t-val of e is true. So if we rewrite by that, or rather the sim of that, because we want to turn this into this. So if we do that, then that should turn this into true, and then the if should fire off, and this should just become this first bit, and then we worry about that. So, yes. Right, so the if has disappeared, just became that first bit, and now this looks like perfectly an instance of the recursive call, which is here on e prime, which is not one of these withered things, so it's safe to just do it here. Like that. Okay, and then here I think it's going to be the same thing again. We can rewrite sim of this recursive call. If go away, and then it's an instance. So a little bit trickier, but hopefully manageable.